Good afternoon, everybody. Thank you for joining us for the webinar session for today. I'm just going to give people another maybe 5 minutes before we start, just to give them an opportunity to join us. So if you can just bear with me, we will start at 2:05. Good afternoon to those who've recently joined us. I just want to make you aware that we are giving people an opportunity to join us. So we will start in about 2 minutes, so at 2:05. Okay, good afternoon, everybody. Thank you for joining us in our third webinar in our World Space Week webinar series with the theme of celebrating women in space. Today's webinar will be presented by Dr. Rendani Nndanganeni. Dr. Rendani Nndanganeni is a space weather researcher at the Space Science Directorate of the South African National Space Agency in Hermanus. Her research focus is studying the impact of space weather on the aviation sector in South Africa. She completed her BSc in Computer Science and Physics in 2006 at the University of Venda and went on to do her BSc Honors, Masters, and PhD in Space Physics at Northwest University. She joined SANSA in 2016, first as a postdoctoral research fellow. She is currently working with key role players in the aviation sector, such as the air traffic navigation services, to understand the effects of space weather on communication and navigation systems in order to provide information to assist in ensuring air navigation safety. Her research is playing a vital role in assisting South Africa in aligning itself with international standards for the provision and access to space weather information in order to meet the International Civil Aviation Organization recommendations. Her webinar for today is titled Making Research Count. Before we commence with Dr. Rendani's presentation, I'd like to remind everybody again that throughout this webinar series, we're running a competition where winner will be will win a goodie bag from Santa. And in order to be a winner, you just have to answer the questions that are posed in each of the webinars. So today's question is, name at least one industry that can be affected by space weather. You can email all 5 answers to spacesci-info@sansa.org.za. The email address will also be posted on the chat box. Also, lastly, if you have any questions, please put them in your in the chat box. And at the end of the webinar, at the end of the presentation, Dr. Rendani will then attend to those. Thank you again for joining us. I hope you enjoy the presentation. Dr. Rendani, the floor is yours.
Thank you, Dr. Katamzi. Can you see my screen?
Yes.
The one with the presentation?
Yes.
Okay. Good afternoon, everyone, and thank you for joining us on today's webinar. As Dr. Katamzi has introduced the topic, it's going to be space weather research, making research count. I thought maybe we should actually start with the definition as to what research is. Research is a search for facts and knowledge. That is according to the dictionary. If you're using it as a noun, it's a diligent and systematic inquiry or investigation into a subject in order to discover or revise facts, theory, and application, or a particular instance or piece of research. That's more in general what the dictionary is saying. And as we move forward, again, if you look at this picture, which means you have to search, you analyze, you have a data, and again, the cycle is continuous because you search and then you get for answers and then you analyze your answers, whether depending on the data or the fact that you have. And then you have to define certain methodologies according to a field or academic disciplines. And then a research develops our critical thinking skills and gives us understanding and provide us with an information that we can apply or use on our daily life. So today we're going to talk about space weather. And the contribution that research into space weather made into our daily life, our daily operation, with the focus mainly being on the impact on aviation industry, as Dr. Zama has introduced, that my work is basically along that area. So what is space weather? We refer, space weather is the conditions on the sun and in the solar wind, the magnetosphere, ionosphere, and thermosphere that can influence the performance and reliability of a space-borne and ground-based technological system. And space weather is the consequences of the behavior of the sun, the nature of Earth, a magnetic field, and the location, sorry about that, in the solar system. So if we're talking about space weather, which means we are talking about what is happening on the sun and how does that influence our technology either in space or on the ground. What we like to say is famous here is when the sun sneezes, the Earth catches the cold. So how so? If you look into this picture there, you can see that there's material that is being ejected from the sun, and then it actually reaches, sorry about that, to the Earth. So the research into space weather, so which means you have to study what is happening in the sun, and then based on that, you have different events as listed here. You have what you call a solar flare, which is a flash of light that actually released from the sun and takes about 8 minutes to reach the ground on the Earth. So you only have about 8 minutes to give the warning. So, and then at Earth, these solar flares actually ionize the upper atmosphere of the Earth. So, and it also have impact on different systems. Here, the example that is given is the railway line and the electrical circuits. It can also impact your high frequency radio communication. And the high frequency radio communication is utilized by, for example, the emergency service, the aviation industry, the airlines, and also the defense force and so forth. And then the second one is the coronal mass ejection. This can take up to hours and to few days to reach Earth. And then this actually resulted into geomagnetic storm, which means then it disturbed the Earth magnetic field, and it can produce what we call geomagnetic induced currents. This can actually affect your power grid, which means you can have your transformer overheating because it's getting excessive charge particles from as a result of this magnetic storm, and also the railway line. And this does not only apply at the high latitude, as it was said before, but it also affects areas in the mid latitude, like where we are, and also the low latitudes. And the other one is the solar winds. That can also be linked to the geomagnetic storm, can also cause the ionospheric storm. And this can also result into the global navigation system loss of signal. And as you know, almost everybody, when you're looking for direction, you just press on your GPS and say, okay, I want to go from this point to this point, and then you get the information or the direction. So if you have a space weather event that is happening, it has the potential to impact your navigation system and your GNSS loss. You can lose signal. So this is important. How? Because then you need to have accurate information. This is not only important for aviation industry, but also it applies to if you are doing global trade, because the accuracy and the timing is very important. You can imagine, for example, if you have to do a transaction for a large sum of amount of money between the two countries or between the two entities, the timing is everything, because if you have incorrect timing, and then there can be mistake that can happen, or we can lose that amount of money, or we can have it to the incorrect account, and that can lead to a very consequences, because then there's a loss of money. And then you have also here the radiation storm that cause single event effects. This is mainly on the avionics, the electronics of the aircraft. So you can imagine what happens if you have that. Then you have a memory bit failure into your system, into your engineering system of the aircraft. Keeping in mind that if you're flying, you are up there, you can't just say, oh, excuse me, now I need to pull over. So you need to take into account those things. And also they need to have an understanding of how this thing can affect the operation so that we can mitigate. And I already, this single event effect can also result into the GNSS loss of lock, which is also an important factor because then it affects the whole system and how they operate. So what are the different impacts that space weather can have? We can see here you have the sun there. Note that the object, they are not out to scale. So you can see from the sun, you have the cosmic rays, the solar wind, and then all of these can lead into the computer upset and the failure. You can see the panels there for the satellite, and then also the safety for the astronaut due to the radiation that is being emitted by cosmic rays and the galactic cosmic rays. Then for the satellite lifespan, it can be affected by atmospheric drag, which can reduce its lifespan. And also space weather can affect the navigation system, which means if you don't have accurate information that is being transmitted to your aircraft, for example, it can also affect how the pilot and the air traffic controller in the ground can communicate between the two. So you can imagine if you now have to reroute your aircraft to a lower altitude, but then if you don't have the communication, then it becomes a problem. And also in terms of when you have a space weather event, there will be an event where you need to reroute the aircraft because then there is a severe space weather event going on that can lead to an excessive exposure to radiation due to cosmic rays, either from the sun or the galactic cosmic rays. And also there can be a radio wave disturbance. For aircraft, it's a requirement that they should have a two-way means of communication, which means they can either use GNSS, and also they need to have a backup, which is a high frequency communication. All of those things, they get affected by space weather events. And as I've already mentioned, space weather events can also have impact on the power grid and also on the telecommunication system. So your phone lines might be affected by the space weather event. So understanding the research of how these systems are interconnected and how we can actually mitigate this can help improve the aircraft safety. So why aviation specifically? It's because then safety is critical. It's of importance. Like I said, while you are there, up there on the air, you can't just say, okay, I'm just gonna pull over like you're on the road. It's easy. Up there, you need to have everything working correctly and accordingly. So, and the communication plays a vital role. So there should always be a communication between the air traffic manager and the air traffic controllers. So, and when you're flying, you are aviating because then you'll be going, and then you have to navigate where you're using the global navigation system, and then you communicate using the high frequency communication. All of these utilize the upper atmosphere layer, which is the ionosphere. And this layer is getting affected by the space weather event that take place. And also in terms of radiation that will come as a result of space weather event, that have an impact in terms of increasing the single event upset, where you have a memory bit upset in terms of the computer box, and also can have a potential in terms of increasing the exposure to crew members and pilots in terms of the dose that they are receiving when flying. So I like this picture here because it actually illustrates nicely about the space weather event, and then what are the different systems that are being affected for aviation. So you can see here, if I go horizontally, you have the solar event, the solar flare, which I've talked about, and then the coronal mass ejection, the solar wind, and the galactic cosmic rays. And then you have the secondary effect, which is the X-ray emission, ultraviolet emission, the radio burst, and the solar energetic protons, and then the plasma, and then the solar energetic protons again, and then enhanced radiation belts. And then effect on the Earth system. Remember, because we are talking about what is happening on the sun and how it affects the Earth system. So you have increased ionospheric density. Remember, the ionosphere is the most important layer that is used for transmitting radio signal waves. And then if you have ionospheric disturbances, which means those signals, you can either have it degraded or you can have absorption, a total absorption in terms of the high frequency communication. And I will give the example of this. And then you can have a geomagnetic storm, as I've explained in the previous slides, that is as a result of coronal mass ejection. And I'm sure you have heard about the northern lights, the auroras that occur as a result of a geomagnetic storm. And then the radiation that is due to galactic cosmic rays that are coming from the outer space. These have a potential of increasing the radiation that the pilot are being exposed to, and can also interfere with the electronics of the aircraft in terms of causing the single event upset for the electronics. And then you have ionospheric scintillation, which actually distort or degrade the GNSS signal or GPS signal. And this can cause a sporadic loss of log for GNSS, especially near the equator and post-sunset. So if you're looking at the solar flare, for example, in terms of the passengers, it will have an impact. If that solar flare is accompanied by a solar energetic proton, then that can enhance the level of radiation at aviation altitudes. And the coronal mass ejection also, if you have a geomagnetic storm and the solar energetic proton, you can actually see that that also will be affected, and also the galactic cosmic rays that will affect the radiation enhancement for aviation altitudes. And then in terms of the avionics, this is the electronic of the aircraft. So the impact is due to the solar energetic protons for the solar flare, and then the solar energetic proton also as a result of the coronal mass ejection, and also from the galactic cosmic rays. For the high frequency communication, you can see that it's affected by almost everything, because then you have for X-ray, then you have the impact on the HF communication. You can either have a total blackout or a partial, but this only happen on the sunlit side. So if it is happening, if the solar flare is happening now, at this time as we speak now, so which means will be affected because it's during the day. But if it is in case that is happening during the night, it will not have any impact on our side. And then that can also be affected by the solar energetic proton and then the coronal mass ejection. And then the global positioning system, or the WAS, is actually affected by almost everything. All of these space weather events affected except for the galactic cosmic rays. And for the satellite and navigation communication, it's affected by all the space weather event or the space weather storms. So it's very important that the research into how the system get affected, and then try to find a way to mitigate also. And this also comes in terms of when the people who are designing the satellite or the different system, they need to have knowledge about how space weather can affect their system, either on the ground, whether it's a ground-based instrument or it's a space-borne instrument. because they need to actually make it space hardened and taking into account the effect of the space weather. And then also the low frequency communication also, it get affected by the solar flares and the radio burst and then the coronal mass ejection. And lastly on this one is the air traffic control facilities. The communication means that they used to communicate between the ground based people in the operation room and then the pilot. It get affected also by the solar flares and then the coronal mass ejection. And also they use something called the CPDLC, which is the controller pilot data link communication. This can also be affected by space weather in terms of if the satellite is unusable and it's affected. So it can also affect this system. And as I've already mentioned, it can degrade the performance of navigation and surveillance that rely on the global navigation system and automatic dependent surveillance broadcast, ADSB, and auto-dependent surveillance contract anomalies. So you can actually see just based on this, how important the research is, understanding the basic research that goes into understanding the space weather impact and also how does it affect the daily operation in terms of the aviation sectors. So this is just showing you what I've been explaining. So you have the sun that release these very relativistic protons, solar radio burst, and then they can actually, when they reach the ionosphere, they can cause what you call polar cap absorption, and then the excess ionization into the ionosphere. If you have that, this can lead to degradation and loss of log in terms of your GNSS navigation and timing, and which means that it can actually affect the signal that the aircraft is receiving now. It might be off or it might have some errors, or you might find that you have something that we call ghosting. So the aircraft is receiving two different signals. So which one then you have to take? And then you have also communication degradation, where you have total absorption is a result of a solar flare that is happening. So an example is in 2015, there was a solar flare, an M-class solar flare that actually caused some of the European country, they have to close the airspace for that period where the solar flare was happening. The reason for that, it was that they couldn't see the aircraft on their radar system. So the problem with that is if you can't be able to see how many aircraft you have on your airspace, and number one, you won't be able to reroute your flight. You won't be able to tell them to change the altitude or to change the route position. So the safer way will be to say, okay, all the flight that has not take off, they should stay grounded. The ones that are en route, then you can just keep them at the same altitude instead of rerouting them, because if you have a case like this, where you can actually tell how many flights you have in space, then it will be difficult also to reroute, to say you can flight A can move to a lower altitude or you can move to higher altitude. So to avoid accident and collision, then they just decide to say, okay, then they're gonna ground the flight that has not taken off already, and the one that were already in flight, en route, they just decided to keep them at the same altitude. But then you have to remember, this has to come at a cost. It comes at a cost, because you can imagine if now you are saying you are grounding the flights, so you have to take into account people who have connecting flights. How are you gonna actually make sure that they don't miss their connecting flights? The pilots who have to work certain hours, and the crew members, now they're working extra hours, so which means you have to add additional income for those ones. And also, most importantly, the fuel, because in order for you to move from your departure point to a destination, you must have a certain fuel. Then when you reach your destination, then you refuel again. So you have to take that into account, and that comes at an economic cost. But if you have this information beforehand, if you have space weather information beforehand, you include it as a part of your flight planning, you can take that thing into account, saying, okay, there is a space weather event that is being expected. So maybe we need to have one stop in between before we reach the destination point. And then they can plan accordingly to avoid this unnecessary extra cost and all those kind of things. Although we cannot predict what the sun is doing, but we have some means of predicting based on the information that is from the satellite and the ground-based instrumentation that can tell us what is the probability of solar flare happening, or a coronal mass ejection happening, or a geomagnetic storm happening. And this, it can actually help the aviation industry to actually save some money in terms of the cost, in terms of if they have to ground the flight, if they have to do additional fueling, if they have to do additional stop, and all that kind of things. So here next is then an example of a solar flare that happened in 2017. As you can see, it's an X9.3. This was the largest solar flare that was observed. But I want to bring your attention to this red thing here. You can actually see for the whole of African region and some of the European region, it was red. What does that mean? It means that there was a total absorption in terms of the frequencies. It means at that time, the lowest frequencies, you can see up to 10, it was not usable. And you can see that it actually here is saying, how long does this event lasted? It actually lasted at high latitude for 4 hours and 39 minutes, at mid latitude for 2 hours and 12 minutes. So if you didn't have that information beforehand, then it becomes a problem, because then now you are flying over there, but then you say that they can't be able to communicate between, there's no communication between the pilot and then the air traffic controller or the air traffic managers. So because then they have this information beforehand, then they can try and find what the device, what is other alternative communication means that they can use for that moment when you have this event happening. And at this time, there was, for example, a report that for about 90 minutes, there was a loss of communication within the marine and also with the cargo plane in terms of the aviation. So what I'm trying to say is, what I'm emphasizing is the importance of understanding the impact that space weather have on the daily operation of the aviation sector, and understanding the different storms and what different impacts that it have, either in terms of communication or in terms of navigation, and also in terms of radiation exposure. And here is just an example of, you remember on one of the slides, I did talk about the impact in terms of the grid, the electricity grid. So due to ground-induced currents. So this is an example of an ESCOM transformer that was damaged due to a geomagnetic storm that happened in 2003. So you can see that they give that it lost 15 by 400 kV transformer. You can see the damage there. That was in October 29, 2003. So you can actually see what the costs are. So this is between 10 to 13 million, not rands, but the US dollars. And then the replacement time can take anything between 12 to 18 months. And another example was in March 1989, a Quebec power grid collapsed within 90 seconds of the space weather event happening. And the cost went up to about $2 billion US. So you can actually see how the more we do research, how we can actually improve our understanding of how these things impact us. And in a way, if we know that there's a geomagnetic storm coming of what magnitude, then the owners of the instrument or the electric grid, they can actually mitigate. They can either put their transformer into, switch it off into a redundant mode where it's not gonna be operating fully. And then we can say, okay, they can just monitor how the event is progressing. And then after that, they can switch it back on to operate in a full mode. But this is just one of an example of what happened, the impact that it had within South Africa. So this is still that picture that you saw, but this is just inside. Now it has been zoomed in, but it's still indicating the damage or the extent that space weather event has on that transformer there. And I think that's the end of my presentation. I thank you very much for your attention.
Thank you, Dr. Nndanganeni, for that really interesting presentation. I don't see any questions on the chat box. So if you please, if you have any questions, please populate them in our chat box. And maybe before that, I would also like to remind you that the question for today is, name at least one industry that can be affected by space weather. So maybe to just start things off, Rendani, a question that maybe I can ask is, does it really matter on the magnitude of, let's say, the geomagnetic storm on the on its effect on radiation exposure at aviation altitudes?
Yes, it does. Because with that one, it's very tricky, because then you remember with radiation exposure, it's a combination from the galactic cosmic rays, which are ever present, and occasionally when you have the severe space weather storm, so which means now you have an additional from galactic cosmic rays and the solar cosmic rays. So they enhance the radiation that you have at aviation altitudes.
Okay. And does it also matter how long the duration of the storm? So can you have a compounding effect, for example, if you have a long duration storm, or if you have successive storms, such that, you know, the overall impact looks like you have a long storm conditions?
Yes, it does. And also you have to remember, it depends also on the time that you're flying. The longer you fly, the more time you spend in air, the more exposure you get. And also the latitude. At high latitude, we have more exposure. At the equator, you have minimum, because then of the magnetic field shielding there. And at mid latitude, then you have much more than at the equator.
Okay, interesting. Are there any other questions from the audience, from the participants? Okay, I think I see a question. So there's a question from Mr. Kajan Lakan. Hopefully I'm saying your name correctly. He says fascinating stuff. If ground current can be termed as soil lightning, how can one protect equipment from these currents? So if ground current can be termed as soil lightning, how can one protect the equipment from these currents?
Like I said, there's nothing much that you can do to protect them. It's just the mitigation that you do is either you can switch off your equipment at that moment, because you will have the information beforehand that there's a probability that you're going to have a space weather event. You're going to have a G1 storm impacting the earth on tomorrow, for example, at a particular time. So you can switch off your equipment for that period of time, so to avoid getting excessive heating or for it to accumulate that excessive current than the normal one that it normally gets.
Okay, so hopefully that answers your question, Mr. Lakan. Another question from Douglas Moyeni reads, you stated that the current model can predict space weather events. However, from all the talks that have been hosted here, I thought it's only observe and reporting. So I think Mr. Moyeni says that he thought that we are only doing observation and reporting of space weather events and not prediction. So maybe can you clarify on that?
Yes, in order for you to report on what is happening, there is models that are being used. In order for us to generate the bulletin or those warnings that you're talking about, we check the condition on the sun and then look at what the different models are saying, and then we can give that information so that we can give the accurate information. I don't know if that answered the question.
I hope so. But yes, I think so, because basically he just wanted to know that we wanted to clarify that there is not that SANSA doesn't only do observation and reporting, but also does some forecasting of space weather events. I don't know if maybe you can do take it a little further in terms of what type of forecasting that is done. But I think he attended yesterday's talk because the forecasters were talking about forecasting, which means you actually observe the current conditions and then forecast what the impact of the conditions will be on Earth, and particularly in our South African in our African longitudinal sector.
Yes. Yeah. The forecast that they're talking about is like I said, the research is the basis of everything, even the forecast. Here we have I think about 8 researchers who does research into the ionospheric physics, plasma physics, magnetism, space weather, you can name them, solar physics. So there are different models that are being developed just to understand the impact of space weather. How does the ionosphere behave at what different condition, whether it's a solar minimum where the sun is less active, or during solar maximum where the sun is active. And there are models that are used in order for us to understand those things. And the models are designed for different, you can have models for different latitude and longitude, so you can understand the different conditions, because space weather have a regional impact. It's global, but it has a regional impact. It affects different regions differently. So you need to understand how your region is being impacted.
Okay, Thank you for that, Rendani. The second question from Douglas says, at what condition will occur? Okay, which conditions on the sun, occurring on the sun will trigger a warning on aviation?
If you, am I still sharing my screen?
No.
No, okay. Let me just go back to. If you remember, I had a chart where I was indicating the aviation system that get affected, and then the different solar storms. Let me just see if I can find it and share. Can you see?
Yes.
I don't know if you are seeing the correct one. Can you see this one where I'm pointing?
Yes, yeah.
Just want to do it on the presentation mode. Okay, it doesn't want to do. So, but here you can see a solar flare does affect the avionics, the high frequency communication, your GPS and GNSS. So when you have solar flare, the coronal mass ejection, which also results into the geomagnetic storm. So you can give the warning for all of this, because like I've explained, you have all this system, the solar flare, coronal mass ejection, the solar wind, and galactic cosmic rays. They affect almost all the aviation related system, whether it's passenger crew that is due to being exposed to radiation exposure, the avionics that where you have single event upset or single event effect, where you have upset in the memory bit of the computer, or the high frequency communication that is being affected, where you have the absorption, like I showed in the map, where you saw our African continent and some of the European region, where you have it was covered with red. So which means your frequencies was not usable, whether it's your GPS or your wide augmented system, where you won't be able to navigate because your navigation system will be down, or whether it's your satellite system where the communication is not there because of this space weather storm that is happening, or in terms of your air traffic controller system, which will be affected by solar system, and then the solar flares instead, and then the coronal mass ejection. So I don't know if that answered the question. So solar flares, coronal mass ejection, and galactic cosmic rays, they all affect the aviation system one way or the other.
Okay, thank you, Dr. Rendani Nndanganeni. The question, we also have a question from John Bosco Habarulema. He says, hello all, is it not possible to have instrumentation everywhere which necessitates development of models for helping in forecasting and nowcasting of different space weather phenomena?
If there is money, that would be very great, because then you can get a good coverage of overall over the whole region, and that will actually increase the accuracy of your model. So your model results and the observation will give you the closest approximation or the true picture of what is actually happening. So if there is money, that would be great to have all the instrumentation all over. Thank you.
Thank you, Rendani. Then the next, the last question is, during the period whereby the sun is active, so in its 11-year solar cycle, do you advise all planes to be grounded, or is there a different approach?
No, we don't advise them to ground their planes. we give them the right information to equip them to make the right decision. Because the problem is, like I said, you cannot control what the sun is doing. And sometimes when you're doing prediction and the model, you can have the false negative and the false positive. So you can say now you have a space weather event that is coming and it will be of this magnitude, but then along the way, it can either reduce in speed and the impact will not be as much as you first predicted. So if you say there will be a space weather event of this magnitude, then you need to ground your plane and then it doesn't happen, then that industry lose money. So what we do, we are equipping them with the right information so that they can make the right decision. So we don't tell them that, oh no, there is a solar flare coming, then you must not fly at all. We say there's a solar flare happening, be aware that there might be an impact in terms of your communication and then the navigation. So you must be aware of that so that they can actually say, okay, if we lose HF communication, for example, what alternative method of communication can we use so that we can maintain that constant communication between the air traffic controllers and then the pilots?
Okay, thank you for that response. I do not see any other questions on the chat box or on the Q&A box. So I would therefore like to close the webinar by thanking Dr. Rendani Nndanganeni for her very exciting and interesting talk. And maybe just note, which I should have done in the beginning, that the webinar was supposed to be delivered by both Dr. Rendani Nndanganeni and Dr. Matamba, Chimakato Matamba, who unfortunately could not be here with us. But Dr. Nndanganeni actually covered the material very well. Thank you very much, everybody, for joining us for today's webinar. I'd like to remind you that we have 2 more webinars planned. One tomorrow around data that is used in space weather research and applications. And on Friday around outreach and creating excitement and awareness about space weather in the general public and at our schools. So please do join us again tomorrow and Friday at 2 o'clock. And lastly, just to again remind everybody, the question for today was name at least one industry that is affected by space weather. Thank you and have a good afternoon.
Thank you.